Hello everyone. Today we are going to study another new technology of ultrasonic testing, time-of-flight diffraction, or TOFD for short. Firstly, the basic principles of TOFD are introduced. TOFD is detected using the diffracted waves of defects. Diffraction refers to the phenomenon that waves continue to propagate around the edge of an obstacle, as shown in the figure. During inspection, the probe receives the diffracted waves from the defect endpoint and uses the time differences between them to reach the probe to obtain defect form information. Since the energy of the diffracted wave is much larger than the energy of the reflected wave, it is difficult to observe the diffraction signal when a signal probe is used for TOFD detection. So the double probe or multi-probe method is mostly used. For example, two-probe array detection, one probe emits ultrasonic waves and the other probe receives diffracts wave signals. Basic configuration of TOFD testing equipment includes probe, host, scanner, etc. Typically, probes use small chip, short pulse, wideband longitudinal waves. The chip generally adopts composite piezoelectric chip, which can effectively improve the sensitivity of transmitting and receiving, and the diameter is generally not more than 25 mm. The production process is shown in the figure. Gap is first cut out of single crystal ceramic and filled with silicon, then sliced, ground, silvered, stamped, polarized. A TOFD probe is produced. During detection, multiple sound sources are excited at the same time to generate a large diffuse sound beam. Multiple sound sources interfere and superimpose each other at different positions. So, the energy difference between the main sound beam and the diffuse sound beam is not as obvious as that of a single element probe, thus achieving a wide range of scanning. In addition, since workpieces with different thicknesses require different angles of sound wave incidence, the TOFD probe and wedge block are separated by the method, and in different wedge blocks are replaced according to the different needs. The host is the main equipment of TOFD detection. It mainly completes the excitation pulse to make the probe work and relies on the encoder to sequentially record the ultrasonic signal returned from the probe and then amplifies and filters it and converts it into a D-scan image. Storage, analysis, printing, output, and other functions. The scanner is an extension of the TOFD host and is mainly responsible for clamping the probe to transmit signals. Generally, it is also equipped with a preamplifier to amplify and filter the signal. There are three kinds of ultrasonic signals in the detection process, as shown in the figure. One is the straight-through wave, which is the beam sent from the transmitting probe to the receiving probe along the shortest path along the workpiece, as shown in the figure 1. The second is the bottom reflected wave. 2. Reflected from the bottom to the receiving probe. The third is the shear wave reflection formed by the longitudinal wave incident on the bottom surface of the refraction surface composed of defects. 3. Their phase relationship is when an ultrasonic beam propagates from a high impedance medium to a low impedance medium, the beam phase changes after reflection at the interface. If the beam is in a negative period before encountering an interface, it transmits to a positive period after reflection from the interface. It can be seen from the figure that when the beam passes through the upper end point and the bottom surface of the defect, it is reflected at the heterogeneous interface and the phase changes, so the waveform phase is opposite. However, when the beam passes through the lower end point, it is equivalent to that the beam surrounds the bottom of the defect, and the phase does not change, which is similar to the phase of the straight-through wave. According to theory and experiments, if the phase of the two diffract signals are opposite, there must be a continuous and uninterrupted defect between the two signals. And using the time difference between the upper and lower endpoint diffracted waves can calculate the defect depth and its own height, which is also one of the outstanding advantages of Tofd technology. During imaging display, the image of Tofd is a grayscale image of black and white, as shown in the figure. The amplitude is represented by the grayscale. When the echo is at 0 position, it is represented by middle gray. When the waveform changes to the positive half cycle, it gradually changes to 100% gray, white. And when the waveform changes to the negative and positive half cycle, percent gray, degree black gradient, as shown in the picture. For example, when scanning non-parallel welded joints, it displays images such as: when no defect is detected, only the grayscale images of the through wave and bottom reflected wave signals are displayed on the display. When a defect is detected, in addition to the through wave and bottom reflected wave signals, the display screen also displays the grayscale images of the upper and lower endpoints of the defect, as shown in the picture. Let's take a look at some special defect display effects. 1. Open cracks on the upper surface of the workpiece. Its main feature is that there is no straight-through wave and signal at the upper end point. When the defect has a certain length along the scanning direction, such a D-scan image can be continuously scanned. At this time, the direct wave will be blocked. When the surface opened depth is very small, the through wave is not broken. but significantly lacks. 2. Opening cracks on the lower surface. Its main feature is that there is no lower endpoint and bottom wave. When the opening depth is small, the through wave cannot be completely blocked, and the bottom wave does not disappear, but obviously lags behind, as the picture shows. 3. Short defects. Because the distance between the upper and lower endpoints of short defects in the field is very small, there is no obvious difference between the upper and lower endpoints of diffraction, and a very obvious irregular multiple oscillation signal will appear on the display screen. 4. Near-surface defects. Due to the close distance between this near-surface defect and the straight-through wave, it is indistinguishable from the superposition of the upper endpoint and the straight-through wave. 9. Single air hole. Due to the small geometric size, there is no obvious separation of the upper and lower endpoint echoes, forming an independent small crescent shape. The phase cannot be resolved, and it is greatly affected by the diffuse sound beam, and there it will be a long arc tail. According to the description just now, it is not difficult to say that Tfd ultrasonic testing has the following technical advantages. 1. Tofd technology has good reliability because it mainly uses diffracted waves for detection, and the diffracted signals are not affected by the sound beam. Defects in any direction can be found effectively, which makes this technology has a high defect detection rate. 2. Tofd technology has high quantitative accuracy. Diffraction time difference technology is used to qualify defects, and the accuracy is much higher than that of conventional manual ultrasonic testing. It is generally believed that the Tofd qualification error is less than 1 mm for linear defects or area defects. The height measurement error of cracks and unfused defects is usually only a few tenths of a millimeter. 3. Tofd detection is simple, fast, and efficient. Nonparallel scanning, which is the most commonly used, can be operated by one person. The probe only needs to move along both sides of the field, and no sawtooth scanning is required. The detection efficiency is high and the operating cost is low. 4. Tofd test results are more informative, which is conducive to defect identification. In the A-type display, the screen can only display one A-scan signal, which the Tofd image shows a collection of a large number of A-scan signals from weld inspection, which is more conducive to the identification and analysis of defects. 5. The results of Tofd technology test are easy to save and process. The Tofd testing system currently in use are all high-performance digital instruments, which completely overcome the poor signal recording capability of analog ultrasonic flow detectors and simple digital ultrasonic flow detectors, single processing. 6. In addition to detection, Tofd technology can also be used to monitor defect expansion. 7. Tofd can accurately locate the depth of the defect and qualify the height of the defect itself. 8. Since the defect diffraction signal is independent of the angle, the detection reliability and accuracy are not affected by the angle. 9. Determine the position of the diffraction point according to the propagation time difference of the diffraction signal, and the qualitative positioning of the defect does not depend on the signal amplitude. That's all for the basic theory of TDOA ultrasonic testing technology. Thank you for watching.